Now, you've got four chambers, as we said earlier. Two atria, a right and a left atrium, atria is plural, that receive blood from veins, and they pump the blood to the ventricles, and the blood has to pass through valves. These are little flaps that are between the ventricles, and when they contract, the flaps close, and that keeps the blood from flowing backwards. The atria we call receiving chambers. They do pump a little bit, but gravity's on their side, so it's not a great force. The ventricles are larger than the atria, and the walls of them are thicker because they are stronger pumps. They've got to pump the blood up against gravity into either the pulmonary circuit or the systemic circuit. And when they contract, they send blood into arteries, either the pulmonary trunk, where it goes into the pulmonary arteries, or into in the systemic pump, it's going to pump into the aorta and then get delivered all over the body. Now, the atria are not symmetrical in size, shape, or location. The right atrium is larger, the wall is thinner, and it's a little bit more anterior than I said the wall is thicker, the wall is thinner. The left atrium has a thicker wall, and it's a little smaller. And it's mainly on the posterior side of the heart. Externally, the atria have these little muscular pouches on the outside of them called auricles. Kind of looks like an ear. And they will expand so that the atria has more space to fill up with blood. The auricle of the right atrium is larger than that of the left atrium, much larger. Pectinate muscles are inside the front of the right atrium. They are muscular ridges, and the pulmonary veins mainly form the left atrium, and the walls of the left atrium are smooth. There's a septum, the inner atrial septum, a very thin wall that separates the two atria from each other. And in that septum, there's a little indentation. It's called the fossa ovalis. And that's a remnant of a hole that was there that's called the foramen ovale in the fetal heart. And when the baby is born and takes its first breaths, that foramen ovale closes, and you're left with just this little indentation called the fossa ovalis in that septum. Now, the ventricles are also asymmetrical. The right ventricle is wider and the walls are thinner. Now, remember we said the walls in the right atrium were also thinner. The right ventricle thinner. Why? Because it's only going to pump into the pulmonary circuit. It's not a very powerful pump. But the left ventricle has a much thicker wall because it has to pump all over the body through the systemic circuit. It's about 3 times thicker than the wall of the right ventricle. Now, both ventricles have a ridged surface internally and very irregular protrusions called the trabecula carneae. And they also have these finger-like projections of muscle called the papillary muscles. They look like little nipples. And they are attached to the tendon-like cords called the chordae tendineae that are attached to the valves that are between the atria and the ventricles. There's also a very thick muscular wall that makes up the interventricular septum that separates the right and the left ventricle from each other. And it's thicker because the ventricles are your pumping chambers. So you can see here, here's the right atrium. You see how the wall is thin. There's the fossa ovalis in the inner atrial septum. And then here is the left atrium, and you see how the wall is thicker. You can also see how the right atrium is a lot bigger than the left atrium. Then here's the right ventricle. You can see these papillary muscles that are attached to the chordae tendineae, that are attached to the valves that are between the atria and the ventricles. Also notice the interventricular septum, how thick it is. You notice the wall of the right ventricle is a lot thinner than the wall of the left ventricle, because the left ventricle is your systemic pump. In the right ventricle, it's just going to the lungs. The trabeculocardiae you can see in here between them, those irregular looking things there. Now the reason the heart has valves is to keep the blood from flowing backward. It has to flow in one direction from the heart, and that guarantees that the deoxygenated blood that enters the right side goes through the pulmonary circuit, and then the oxygenated blood that is from the left side goes into the systemic circuit. You don't want any backflow. Any backflow would be because of gravity and pressure, but the valves are there to keep it from happening. To keep the blood from going back into the atria after it's passed through the valves between the atria and the ventricles, we have the atrioventricular valves, or the AV valves. And these valves have cusp. And the tricuspid valve has 3 cusps, and it's between the right atrium and the right ventricle. The bicuspid valve has 2 cusps, and it's between the left atrium and the left ventricle. Most commonly, we call the bicuspid the mitral valve. And these are the valves that have the cords of tendon, the chordae tendineae, that attach to those papillary muscles. So when the ventricle contracts, the papillary muscles pull the chordae tendineae, and that's what shuts the tricuspid and the bicuspid, or the tricuspid and the mitral valves, so that the blood doesn't go back into the atria. What keeps blood from flowing back into the ventricles when they pump the blood into the blood vessels is the semilunar valves. And so this is where we're going to have problems with gravity. They're called semilunar because they kind of have a half moon shape with their 3 cusps. And they're named according to the artery where they're found. So the pulmonary valve is between the right ventricle and the pulmonary trunk. And the aortic valve is between the left ventricle and the aorta. And those cusps that you see here, when the blood flows through the cusp, this is when it's open, it starts to flow back down because of gravity. And you can see how those cusps fill up with blood to keep it from happening. It squeezes it shut. This is the cusp of the tricuspid and of the mitral valve. So if we're looking at the flow of blood through the heart, and this is a big hint, you've got to know this. When you get into the nursing programs and the other allied health programs here at Wallace, they'll often say that you don't know the blood flow through the heart. I know you were taught this. So throughout the course of this semester, I may throw up a little quiz about blood flow through the heart. So you have to learn it, okay? So if you'll follow me with my little mouse here, we'll go through this. All right. Blood is in the systemic circuit. It's all over the body. It's been pumped by the left side of the heart from the left ventricle. And it goes up, goes all over the body, gives out oxygen, and picks up carbon dioxide. So carbon dioxide or deoxygenated blood travels through the systemic vein, which is called the inferior vena cava if it's coming from below the heart or below the diaphragm, and the superior vena cava if it's coming from above the diaphragm, and it empties into the right atrium. The right atrium will squeeze a little bit and push the blood through the tricuspid valve into the right ventricle. When the right ventricle contracts, it closes the tricuspid valve and sends blood up through the pulmonary valve into the pulmonary trunk, which branches into the two pulmonary arteries. You got the left pulmonary artery and the right pulmonary arteries, and it goes to the lungs where gases are exchanged and it becomes oxygenated. And then that oxygenated blood re-enters the heart through the pulmonary veins, and it goes to the left atrium. In the left atrium, it will contract and push the blood through the mitral valve into the left ventricle. The left ventricle contracts, that closes the mitral valve, pushes it up through the aortic valve into the aorta. And then that aorta starts having these branches immediately of other arteries that will pump it through the systemic circuit, and it starts over again.